Welcome back, guys. I hope all of you will be fine. So this is question 3.31 of chapter 3. Based on extensive testing, it is determined by the manufacturer of a washing machine that the time y in years, okay, so in years the time has been represented as y before a major repair is required is characterized by the probability density function, which is given by f of y, and that is 1 by 4 exponential of minus y by 4 for all the values of y which are greater or equal to 0 and 0 elsewhere. Okay, so what do I have to find out? On the basis of this probability density function, I have to find out the answer of two parts, and the first part of it is a. Critics would certainly consider the product a bargain if it is unlikely to require a major repair before the 6th year. Comment on this by determining probability of y greater than 6. Okay, so what do I have to find out? I have to find out the probability that a major repair will also be required after the 6th year, because during this time it will need a major bargaining. Okay, so therefore what I have to do, let me write here the solution. Okay, and in solving it, what do I have to do? I have to find out the probability that y is greater than 6, and now let me find the f of y, which is the CDF for this one, because this is now the PDF and its CDF would be f of y. Okay, so now in order to do so, let me find it out, and here in order to find it out, we have to find the CDF for it for all the values greater than 0, and for that let me use the same function here. Here I am already writing the constant outside of my integral, and here writing it from the lower value up to some arbitrary value, let me take it y, and changing the domain of my function from y to t, okay, as we have been doing previously. So exponential of minus t by 4 and here d of t. Okay, so now integrating it, what I will get here, I will get 1 by 4 multiplied by exponential of minus t by 4 divided by minus 1 by 4. Okay, so these two will cancel out, and here the ranges of it will be from 0 to y. Okay, so now let me write them here, and here it would be minus exponential of minus t over 4, and it will be from 0 to y. Now writing these ranges, what I will get, first writing the higher range here, what I will get, minus exponential of minus y by 4. Okay, and then this range which is 0, so minus exponential of minus 0 by 4. Okay, so now after it I will get what, it will be minus y by 4, and here exponential of 0 is 1, so here I will get minus 1. Okay, or ultimately from it the f of y will be what, rearranging it, this minus will be plus, so I will get here 1 minus exponential of minus y over 4, and that is the CDF of the required function. Okay. So now taking it and putting it here, by putting the value of y equal to 6, what I will get here. So in order to find the value of the probability of y greater than 6, what I can write? I can write here 1 minus f of 6. Okay, because these will be the higher values, and for them I have to subtract the lower values from 1, so that's what I will get. So I will have here 1 minus, here the value of f of 6 would be 1 minus exponential of minus 6 by 4. Okay, so opening this bracket, these two will cancel out, and ultimately I will get exponential of minus 6 by 4, which will be 0.2231. Okay, so that is what, that is the answer of part A of my question, which is around 22.31%, which is not low. Okay, so here I have to consider this value as well, because this is the 22% and which is not low. Okay. So, now going to part B of my question, what is the probability that a major repair occurs in the first year? Okay. So, here in order to do so, let me move down somehow, and here in order to solve part B of my question, the probability that the year will be less than or equal to 1, and this is what, this would be the f of 1. Okay. So, now in order to do so, taking the same function and writing the value of y equal to 1, what I will get, 1 minus exponential of minus 1 divided by 4. Okay. And from it, what I will get here, from it I will get 0.2212, which is basically the solution of part B of my question, and this value is not also lower, and this is also around 22.12%, and this is also a very major constraint in the product, because it will also require the major repair within the first year, and the probability of it is around 22%. Okay. So, that is it for today, in which we have seen the usability of CDF in the product lifetime and how can we use it for the product lifespan. If you have any question, you can ask me in the comment box. See you soon.